All right, hello class, and welcome to week 4, day 4 expectations. Today we're going to be going over the expectations, and then I will also be doing the close reading afterwards. So if you need the close reading, continue to join me. If you don't need the close reading when we get to that time, feel free to hop off. What we're doing today is starting with that close reading where we're underlining and highlighting important information, writing down questions or ways that you relate to the material. Again, I'm looking for about one per paragraph. This should feel like an academic task, like you're doing work. It's more than just reading. Again, it's close reading and showing me that you can engage with the material. This is a really important skill going into high school, going into 8th grade. This will begin on page 63 of the PDF. After that, I want you to respond to a question or respond to this task of explaining the difference between oxidation and digestion. You're going to need to do the close reading in order to be able to do that. This should be in complete sentences, again, practicing our writing skills, making sure that we're ready to go into 8th grade, ready to go into high school. In addition, I want you to journal everything you eat in one day. This can either be today or the next day, either like Thursday or Friday. Just everything that you eat in one day, and then I want you to compare it to the food pyramid. The food pyramid is a little bit outdated. However, it does point to important food groups, so I still think it is valuable. After that, I want you to complete any math homework from Ms. Moore, review and practice movements from mystery class, and then also make sure that you are moving for the day, such as going on a walk. I know a lot of students have been going on walks, skateboarding, or just doing exercises at home, and they've been a lot happier for it, so just make sure your heart is pumping. Again, as a review, we have close reading. Respond to this question of explaining the difference between oxidation and digestion. Journal everything that you eat in one day, compare it to the food pyramid, math homework, movement for mystery, and then make sure that you're just moving in general. All right, let's dive into the close reading. Nutrition. Every day we move, grow, learn, and eat food. Movement goes on constantly inside our bodies while we're not even aware of it, in the form of life processes. If you're thinking that young people do some of these things more than adults, you're right. That's why young people like yourself need to eat at least as much or more than adults. Because young bodies are growing and developing, what people eat when they are young affects them all their lives. It's a good idea to know something about what you eat. Some people say you are what you eat, but have you seen a whole lot of people looking like sliced cucumbers, fried chicken, or peanut butter and jelly sandwiches? Maybe it's better to say that your food becomes you. Food makes it possible for you to do all things you do. Have fun, play chess, play soccer, sculpt clay, ask questions, make music, bake muffins, not to mention pump blood, fight infections, grow taller, think thoughts, and feel emotions. So how does what we eat affect all of these things? Food and oxidation. In earlier lessons, we learned quite a lot about what we eat. We know that all our food begins with the sun and green plants. Photosynthesis is the process that puts the energy of the sun into the food we eat. How do we get the energy inside us? Chewing and swallowing food isn't enough, nor is breathing. But both are a part of it. Photosynthesis, which captures the sun's energy and transforms it into food that we can use, takes place inside plant and bacteria cells. Oxidation is the reverse process, the release of energy from that food for our use. This process happens in our cells. Using oxygen from the air, we burn the carbohydrates that are in the food that we eat. Though there are no flames, you can picture millions of tiny, tiny little fires burning in every cell, warming us up and releasing the energy from the sun in our food. When fuels like wood or coal are burned, the energy stored in the fuel is given off quickly. This same process goes in living things, but it happens much more slowly. The burning of food or fuel in the body with oxygen is called oxidation. Oxidation provides the heat energy that human body needs to maintain its proper temperature. Carbon dioxide and water are the waste products of oxidation, and these are given off when we exhale. Does this sound familiar? Oxidation produces the energy that our body needs. Different foods give off different amounts of energy. This heat energy is measured in calories. Calories measure the heat that a food can supply as food energy. Food and nutrition. Food supplies far more than just heat energy for the bodies of living organisms. The food we eat is a complex mix of molecules, and it is more than that, too. We understand how some food molecules nourish us, others we have more to learn about. The science of nutrition is a young science. We've been puzzling about how food nourishes us for about 200 years now. It is just the last 50 years that what we eat has changed. Since World War II, huge food factories have been mass producing food products. Much of what is sold today as food is extremely changed from its original form of meats, milk, vegetables, grains, and oils. Nutritionists are trying to keep up, but we're not sure how some of these new forms of food work inside our digestive systems and bodies. We have learned about molecules in food called nutrients. Nutrients are the molecules in food that we've discovered to give us something that we really need and without which we would get sick. The nutrients in foods are used for growth, maintenance, and repair of tissues and for just being alive. The most abundant nutrients in food, after water, are carbohydrates, fats, and proteins. Vitamins and minerals are also nutrients required for health, but in very small quantities. Digestion is the process of breaking down food into molecules that are small enough to be absorbed by the cells of the body. This is when food becomes you. The digestive system makes food usable in two ways. Chewing and mashing food starts breaking it into smaller pieces, so it'll be usable in the digestive system. Then chemicals break down the larger molecules into ones small enough to be absorbed into the blood. This process starts in your mouth and continues in the stomach and down through the intestines, the duodenum, ileum, and colon. The bloodstream takes these nutrient molecules and circulates them throughout the body. When a nutrient passes by a cell of the body that needs it, an opening in the cell membrane invites it in. Some parts of the foods cannot be used by the organism. These parts can be digested, so they pass out of the body as waste. 1. Explain the difference between oxidation and digestion. Again, that's the task that I'm having you guys do. So here we have a definition of digestion. And up here we have a definition of oxidation. So if you check that out, you should be able to do that pretty easily. Carbohydrates give energy to the different tissues of the body. They cannot be stored for long periods of time in the body, so they need to be replenished or eaten often. Carbohydrates are dissolved into the bloodstream as glucose, which is absorbed by the tissues of the body and oxidized or used as fuel. The two types of carbohydrates that our body uses are starches and sugars. Sugars are smaller, simpler molecules than starches. Sugars are sweeter than starches. The starches get sweet as soon as we chew them and mix them with saliva. This begins to break them into sugars. Imagine a bite of steaming baked potato. At first, it may not taste as yummy as it does after you've mushed and mixed it in your mouth. You've then broken down its starches into sugars. Foods which are mainly carbohydrates are vegetables, fruits, grains, and legumes. The vegetables I just got lost. Foods which are mainly carbohydrates are vegetables, fruits, grains, and legumes. The vegetables and fruits are simply carbohydrates that break down quickly in your body, and grains. And legumes are more complex and break down more slowly. Sugars are called simple carbohydrates and starches are called complex carbohydrates. Fats are also efficient fuel, especially for muscles which demand the greatest part of our food energy. Fats are insoluble, which means they do not dissolve in body's fluids. This makes them an ideal substance for the long-term storage of energy. When more fat is eaten than your body needs for energy, it is stored as fat in your body until you use more energy. Fats are not just for energy. Among other functions, they also supply the materials for the membranes around cells and cell parts. Fats are good food when consumed in moderation, and active young people need them. Unrefined oils from vegetables and animal foods are good sources. Healthy fats are found in olive, safflower, sunflower, and canola oils. They're also found in vegetables, nuts, seeds, meats, milk, and cheeses. Essentially, fatty acids influence your blood pressure, boost or repress your immune system, alter your perception of pain, and make you more or less prone to allergies and inflammatory diseases such as arthritis. Omega-6 and omega-3 fatty acids are essential to your health, but they are not manufactured within your body. 4 of the healthiest oils to introduce into your diet are olive oil, canola oil, flaxseed oil, and walnut oil. They are all low in saturated fat that is solid or semi-solid at room temperature, such as butter, and these oils have a good balance of omega-6 to omega-3 fatty acids essential to your health. Proteins are used to build and repair body tissues. In fact, body tissues are mostly 75% protein. Proteins are the raw materials for making most of the molecules, such as hormones and enzymes, and the messenger and action molecules, which tells our cells what to do. Unfortunately, in times of long-term hunger, energy needs to take priority over tissue building and maintenance in our bodies. If fats, carbohydrates in the diet are too low to meet energy needs, protein from food or body tissues will be broken down for energy. It's like burning the furniture and wall of a house if you run out of firewood or fuel oil. On the other hand, if we eat more nutrients than we need, whether they are proteins, fats, or carbohydrates, the extra will be stored as fat in the body. Here we have the pyramid. Check it out, but that is the end of our close reading for today, 63 to 67. I hope you guys enjoyed it. There's a lot of important information. These different categories of types of food or types of molecules is really important. And then again, explain the difference between oxidation and digestion. All right, that is the end today. Hope you guys are having a good one.